All right, so we have a definition here. So we have a series, sum n equals 1 to infinity of sum an exhibits absolute convergence if the absolute value of that converges. So it may be that the absolute value doesn't converge, but just the sum converges. So if the sum converges, but the absolute value does not, then it's going to be conditional. So absolute convergence is when the absolute value of the sequence converges. If you have an alternating series that does not, that will converge as an alternating series, but if you take the absolute value of it and it doesn't, then you've got an issue. We actually did a problem like that in the previous video, but I'll do some examples here. They also give us another theorem. If you just find out that this here, if you just get that the absolute value of the sequence converges, then the whole thing converges. Now, let's take a look at these two problems here. Let's do 250 first. We did a similar problem in the previous video, but we're going to do this one first. State whether each of the following series converges absolutely, conditionally, or not at all. Well, if you just write one of those three things down and give no actual explanation or work for it, you're not going to get any points whether or not you've guessed correctly or even knew what it was. Again, so this is calculus 2. You're going to have to actually show why. All right, so let's take a look at this. The alternating series test, we need, number one, we need to show that 0 is less than or equal to b of n plus 1, which is less than or equal to b of n for all n. So let's try that. So let's look at, and again, the bn is this n over n plus 3. So if we take n equals 1, we get 1 over 4. N equals 2, we get 2 over 5. Well, 2 over 5 is already bigger than 1 over 4. So 1 fails. And since 1 fails, and this is an alternating series, the series diverges. And you can say by the alternating series test. All right, let's take a look at this 254, though. And it's an alternating series. But let's take a look at this. Let's take a look at, so the absolute value of negative 1 to the n plus 1, 1 over n factorial is just 1 over n factorial. Because we're removing the other one. We can break them into two pieces, or if I add the extra step, then this equals the absolute value of negative 1 to the n plus 1 times the absolute value of 1 over n factorial, which equals 1 times 1 over n factorial. Because again, these n values are going up. They're not going to be negative, so it's just 1 over n factorial. So let's evaluate this one. So let's use a comparison test. So if we note that, or I guess let's compare to the sum of 1 over n squared. So for n equals 1, we've got 1 over n squared, and we have 1 over n factorial. For n equals 1, we have 1 there and 1 there. For n equals 2, we have 1/4 and 1/2. For n equals 3, we have 1/9 and 1/6. For n equals 4, we have 1 over 16th, and what do you multiply that with? So 1 over 24. And n equals 5, 1 over 25. We multiply this by 5. What do we get at 0? 1 over 120. And it's going to get larger as we go on, meaning the denominator of n factorial is going to increase quicker than n squared. So for n greater than or equal to 4, we have that 1 over n squared is greater than or equal to 1 over n factorial. And since sum of 1 over n squared converges, since it's a p-series with 2 is greater than 1, that implies that the series 1 over n factorial will also converge. And this is comparison test. Now, we've shown that the absolute value of our series converges. That means that this, just the an part, just the 1 over n factorial will converge as well, which we've eventually shown. So this one, I guess we'll do therefore. N equal, excuse me. -1 was n plus 1. 1 over n factorial converges. Absolutely. Again, this work is necessary to show this. You need to show, you can show by alternating series that it works, but eventually you've still got to do this comparison test to do the 1 over n factorial to show that that part of it converges. It's easy to show that the alternating series converges. It's less easy to show this. All of these steps are necessary. If you just write down absolute convergence without doing anything, that's no points.